Okay, so last time, okay, oh crap. Last time we did like acceleration versus displacement graph, I remember. If you guys have any questions, do let me know. Okay, Arsalan, I think we've done one class for this. You can check the recording, it's in the group. Have you been added to the group, Google Classroom?
No, not yet. It's my
Oh,
actual first class. Where I'm checking things out.
okay. All right. So if you join, you can check that recording that we have done up till now. Anyway,
We've done 2 oscillation classes till now, not just one. Sorry to correct you like that.
okay.
Yeah, we've
No,
done 2.
all right, Sanan. If you join, you have to watch 2 recordings. Great. All right. Some questions I gave you guys as homework, which is great. And yeah, pretty much it. Now, today we will be starting with relationship of velocity and displacement. The good thing about this is that you do not need to know the derivation of this, although you can derivate it, but it's all right. And the best part about this is that this equation is also given in the exam. Okay, good. So the equation is that velocity at any instant is given by plus minus omega under root of x naught squared minus x squared. Okay, so this velocity, basically velocity at displacement x, okay? This obviously is the angular frequency. You can find it as 2 pi f if you don't know yet. This is the maximum displacement, also known as the amplitude. All right. And this is the displacement at an instant. So you got to remember that. Anyway, so this equation is given to you, but generally what they do is they ask you this question where they say that what will be the formula for maximum velocity. Now, here we should remember that at max velocity, which is given as v naught, x is 0, because when potential energy changes to become 0, you get maximum speed, and same goes kinetic energy changes to potential. So basically, you will have 0 speed and maximum displacement. Anyway, so you can plug this into the same formula, and when you do that, so V naught will be equal to plus minus omega under root x naught will be the same, but 0 whole squared, because that's when it is going to be 0. So ultimately, you get plus minus omega root of x naught squared. When root is removed, obviously, plus minus just goes away because you square it up. So it's basically omega x naught. And this is the relationship, which is basically you need to remember for maximum velocity. Now, okay. So the next question says, let's state what is meant by simple harmonic motion. Again, for 2 marks, the first mark is always writing that the magnitude of acceleration is directly proportional to magnitude of displacement. Okay. And then you always write that acceleration is always directed towards equilibrium. You can either write it or you can write that acceleration and displacement are always in the opposite directions. Both are actually correct. All right. Any questions, please let me know. All right. Now, going to okay. Okay. So now going to the next question, next part. So you have given something like this, and it says state one time.
Sir, could you show that question again?
Yes. Here you go.
Just one sec. Yeah, okay, thank you, sir.
All right. So the next thing is they have given a graph, and this question will be there all the time. So they say state one time at which this trolley is moving through equilibrium position. Also state the next time it moves through this position. Now we need to understand this, that basically when something oscillates, so this is the equilibrium position. And what exactly is an equilibrium position? Equilibrium position means that here velocity is going to be maximum and displacement is going to be 0. And when it's talking the maximum positions, so here velocity is when it is 0, right? And the second is when it is right here. And that would be, I don't know.
So can you please explain again? Your voice
So,
lagged.
yeah, what I'm saying is that Gatika, something is at equilibrium, right? Like this oscillation. At equilibrium, velocity is maximum. The reason is that the displacement is 0. Do you understand? There, the velocity is 0 and you get the... Because here, the kinetic energy is maximum. Potential energy is 0. Here, kinetic energy is 0. Okay. Thank God. Okay. I hope it's better now. Now. So, hello, Nadia. Now, let's look at this. So basically, at this point, the velocity is maximum, and this point, the velocity is maximum in magnitude, right? So then we have to write this is like this point, and if I see this 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, right? So this would be 0 0.6, 0 0.65, right? Like that. Is that clear? Okay. Now, in the next part of the question, it says the amplitude of this is this. Now, the moment you see amplitude, it means he's talking about x naught here. It says determine the maximum speed. So we already know maximum speed is omega x naught. So do we have the omega? We don't, right? We have to find it. How do we find it? You know that starts from 0 and the one whole wave is still here, which is basically exactly at 1.25. You guys agree?
Yes, sir.
Yes, sir.
Okay, so 1.25 means that omega is given by 2 divided by t times x naught, 2 by 1.25 times, you are to change this because you have to do it in, oh, we don't have to change this because it is in centimeters, so we just keep it in centimeters. Can you please help me find this?
16.1.
16.1. Writing 16 would also be okay. Anything below or above would be wrong. So please do mind significant figures. All right. So always check minimum significant figures. Now, then the displacement when the trolley, for the trolley at half V naught, right? So we have V naught. Okay. So can you do half of V naught, which is half of 16.1? What you get? 8.05.
Yes, sir.
All right. Now we use the formula V is equal to plus minus omega x naught squared minus x squared. So this is your best friend equation. You write 8.05 here plus minus. Okay. And omega is just 2 pi divided by 1.25. And root of x naught was 3.2 whole square. And we want to find x squared, right? So when you square it off, it is going to be 8.05 whole square equals to 2 pi over 1.25 whole square times 3.2 whole square minus x naught square. Can you please find x? Yeah.
So is it 2.8?
It's 2.8. Okay. Obviously, if something goes wrong, it is on Kartika. But obviously, this seems correct because it should be always less than this. So seems correct. You can check the mark scheme later on. All right. Any questions now? Anyone who could not understand this, who still feels left out? Okay. All right. Aman, Ahmed, Fahad, everything is clear.
Yes, sir.
And Arsalan, Mokshit, Javeria.
Yes, sir.
Okay. Munib,
Yes, sir.
Nadia, Smart.
Everything's good.
Right. Okay. Very good. Very good. Excellent. Now, the next thing they ask is they ask to draw a graph. Okay. Whenever the graph you see between V and X displacement, it will always be a circle or an oval, all right, for best. It is usually, you can draw it freehand, but it should look like that. So it's also a good idea to use a compass. Anyway, so right now, the maximum velocity we got was 16.1. So what you want to do is, let's take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, wait. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is not good. So what you can do is you can just simply take 4 like here. If I take 4 here, so then it will be like 1, 2, 3, 4. 1, 2, 3, 4. I'm going to take 8 here. I'm going to draw 1, 2, 3, 4. 12. 1, 2, 3, 4. That's 16. Okay, is that clear? 16.1 will be here. It's best to, even if you don't write it, I mean, it's fine. You can take any point as 16.1 if you want to. Like, you
Sir,
can
can you
just,
go to the previous question once?
yes, why not?
Sir, I
Don't,
don't know why, but I'm getting minus 2.56.
eh? Minus 2.56. Okay,
Yes.
probably then Kartika
I'll
is wrong.
just calculate once again. I'll just calculate once again.
Okay, you put, you know, you've actually shaken my trust on Kartika. So I have to
No,
do it
sir, I
on.
didn't, but I'm just
All right, so right. It's good that I also
No, sir,
check
I
it.
get 2.8 as well.
You're getting 2.8 as well, right? Okay. Mokshit, then probably you are wrong. Yeah,
yes, sir. I'm not.
minus and minus will cancel out. It will be 2.8. All right. Anyway, so instead of doing this, you can just approximately, but make sure that you take the same distance. Like you can take this point as 16.1, right? And centimeters per second. And also write like 2 spaces below, you can write minus 16.1 centimeters per second. And then what you're going to do is, because our maximum displacement was 3.2, so I'm going to find where 3.2 is. So this is 2. So exactly somewhere in the middle of these two, which I believe is 1, 2, 3, 4, 5. So this is 3. 3.2 will be here, right? And similarly, it will be 2. And how sad it is. No, wait. They have done some sorcery here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, fine. So at 5, it is 3. So this will be 3.2. So I'm going to write 3.2 here. And then also on the other side, it's going to be 1, 2, 3, 4, 5. So this is 3, and that is going to be 3.2. Okay, so put a minus sign, and then with just freehand, you can draw a smooth circle. It should be an enclosed shape, and it should pass through the points that you've mentioned, and with a very smooth curve. Do not make any shaky curves here, like this. Is that clear, everyone? Check it, please. All right. So just remember that velocity versus displacement in an oscillation is always a smooth curve, which is like a circle. It could be an oval shape, where this point is x naught, this point is minus x naught, this is v naught, and this is minus v naught. All right. Any questions here? Please let me know.
So we always use the maximum displacement and the maximum velocity.
Yes, the line will always pass through those points, okay? You should always remember that. Okay. All right. Any questions? Please let me know. Interesting. Now, so this is now the next question. Let me see. Probably this question. I want to give you this question as let me see what they have given. No, this is too easy for you, but I'll do this and the next one because it's basically the similar question as I have done, and it also the same graph. So this question you should be doing. So write it as homework. I'll do the first one. Now, in this question, it says that you got a mass of 8-10 grams, and it is the expression. The moment this expression is given to you, it says show that the frequency. You should basically do all the things here. Okay, all the steps. It will give you maximum marks, by the way. So you can write 2x over m times x. You compare it with y equals to mx. A is the acceleration, x is the displacement. So the gradient of this equation is basically minus 2k over m. Now, because what are we really doing here? We should understand that we are basically, let me just do it this way. We are comparing this as a equals to minus omega squared x, right? So it means minus omega squared x is equal to minus 2k over m. And we want to find the frequency, right? So minus minus cancel out. So we're going to write omega is 2 pi f whole squared equals to 2. Now, k is given as 64 check units, it's Newton meter. So everything else should be also in Newton meters. Mass is in grams. I got to change it to 0.810 kg, right? Because everything should be kept in SI units. And now, could you please find frequency and check with this too? Oh,
2.0 hertz.
sorry.
2.0 hertz.
Okay, we are right about it. That's great. All right. Any questions now? Okay. Aman, you're clear. Fahar, Munib, Nadia,
Yes, sir.
Suman, Ahmed, squares.
Yes, sir.
Okay. Arsalan and Mokshit, Munib.
Yes,
Yeah, I
sir.
got that.
Yes, sir.
Okay, that's very good. You guys are smart. And now going to the next one. It says the maximum displacement is this. So the moment you see this, you should remember it is x naught. Calculate the maximum speed. Anybody knows this formula for maximum speed now?
V naught
Go
is
on.
equal to omega x naught.
Yes, easy, right? So this chapter has like just the same pattern. Now we're going to use 2 pi f times. Again, check what is given. So meters, we need to change x naught in meters. Okay, so 2 pi, this is 2. And x naught, we got to change it into meters. So if you were to divide by 100, could you find this, please?
0.2.
Oh, 0. 0.2. Okay, 0.2. Now, why do you think this answer is wrong? Anybody can tell me, please, why 0.2 is a wrong answer?
Less significant figures.
Yes, so if it is 2, you should write 0.20. All right. Again, always check minimum significant. Suman, do you understand this?
Yes, sir.
Okay, never forget. Now, so losing like in 12 questions, if you lose 1 mark in each question, imagine where your grade will fall. So don't do that. Then it says the mass of the trolley is increased. And okay, so mass of the trolley is increased and the initial displacement remains unchanged. Okay, now, so it says what you do then. So it says suggest change, if any, that occurs in frequency and the maximum speed of the oscillation. Right. If you look at the if you look at the formula right here, right? What do you see? Do you see any mass here?
No, sir.
Okay. And the thing is that obviously then we also need to see what is the relationship between frequency and speed with respect to this. So basically, it really depends on x naught if the omega is kept same. But the issue is that if you go back to the equation that they've given us, it is basically acceleration is minus 2k x over m. If you realize this, omega itself, omega squared, depends on 2k over m, right? If you increase the mass, what happens to omega then? It reduces, no?
Yes.
If the omega reduces, then omega itself is related to 2 pi f whole square. So if omega reduces, do you think frequency also reduces? Because 2 pi is just constant, right?
Yes, sir.
If 2 pi is reduced, so frequency is definitely reduced. So we say it decreases. All right. Let me change the color. It doesn't look like I'm solving question. Okay, decreases. What happens to maximum speed? Now, if this is constant and this changes, this reduces, then obviously this will also reduce. Direct relationship. So it decreases as well. Do you guys understand this? Now, I just want to tell you, in any equation, when you're checking it, like how do I know that these are inversely proportional? So you can basically make a bubble around two quantities that you're looking at. If the bubble is slanted, it means they are inversely proportional. And if the bubble is like this, it's not slanted, it's horizontal, then you should know it is directly proportional. All right, is that clear? That is a quick way of checking what is going to happen. All right, any questions?
No, sir.
So you do the next one as homework. That's pretty similar. You need to draw the graph. You learn this. This is even a easier graph than the one we had before. It will be a circle oval shape. So I believe you guys will be able to do that. The next question is a bit different. So I'm going to solve this and you guys follow along. So then it says state one time at which the mass is moving at constant maximum speed. Now, first of all, if you look at the graph itself, you see the graph 0 is here, it is 8 here. It is not something that is divided equally. It means it is on a true scale. Now, I'm going to check what are the maximum minimums. So maximum here, if I see, this will be, I don't know, this will be 15, or I don't know, what will be 15? 14.2468.
14.5, sir.
Yeah?
14.5, if I'm not wrong.
Yeah, exactly. So where is the middle? Is this the middle? I think this is the middle, right? So this will
Yeah.
be 14.5, right? So this is 14.5. And then this one, I believe, has to be, if this is 9, no, this is not 9. 9 is here. So 9.2, 9.4, 9.6, right? So this means this is
9.5 then.
0.5,
Yeah.
right? Now I want to find the middle because I can't find the amplitude without finding the equilibrium position, right? So what I can do is I can subtract them. So if you subtract them, what it might be? 5, I think, right? What do you guys say?
Yes,
Yes.
sir.
You know? Yeah, 5. So 9.5 plus 5 is, what is that?
14.5.
No, I'm sorry. 9.5 plus 2.5. I got to go half. This whole is 5. I want to go in the middle. So that would be 12, right?
Yes, sir.
So it means
Sir,
this, yes.
I did something quite different. I did 9.5 plus 14.5 over 2 to just find the answer. And the answer
Yeah,
is 12.
that's also correct. You could got the mean of those. That's very
Yeah.
nice.
Yeah.
All right. You can find the change or you can do this. This is the equilibrium point. First of all, we got to find this. Without doing this, you can't find the answers to below. All right. So first of all, it says state one. So I'm just writing here always. So you guys can always find equilibrium on real axis. Okay. Anyway, so one time with the mass is moving maximum speed. Now this is a displacement time graph. When the displacement is 0, it is at this point, it is at this point, it is at this point, at this point. You agree? So all these points, displacement is 0. How do I know this? Because this is the equilibrium point. All right. So it means this time got to be this one, which is 0.1, right? So I can write 0.1. And that's my answer. Is that clear? Anyone who could not understand this, please let me know. Okay. Oh my God. Flu is killing me. At one time, it has maximum elastic potential. The maximum. Walaikum salam. अच्छा अच्छा, आप बेल बजाएं, ऊपर गए, सेंटोरस अकेडमी जाना आपने। वन फाइव सेवन मस्जिद के साथ एक दुकान है, उससे आप पूछ लें कि मैंने 157 जाना है, वो आप बता दें जी। हाँ बेल बजाएंगे, हाँ बेल बजाएंगे, इनको कहें सेंटोरस अकेडमी जाना है जी। यस यस ओके थैंक यू ऑलराइट नाउ so then it says one time in the maximum elastic potential. Obviously the elastic potential energy will be maximum when potential energy is maximum and the potential maximum displacement is maximum. So it is here, 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 here. So you could take 0, write 0. Is that clear? Any questions? Let me know. You can write other times as well if you want to. It's fine because they're not asking you any particular one. Then says use the data in figure to determine the motion of the mass. So frequency, right? We want to find omega. So what you do, you know, it starts from here, which is 0. And the next time the same comes is here, which is 0.4. So time period is 0.4. You do omega equals 2 pi by t. So you do 2 pi over 0.4. What you get?
15.7.
15.7 radians per second. You just write it. You can also write 16 if you want to. Then it says calibrate the maximum speed. Who can tell me what is the formula for maximum speed?
V is equal to omega, V naught is equal to omega times x naught.
Exactly. Now, how do you find x naught? X naught is the amplitude. Can you find the amplitude? What that might be? This distance? 12 minus 2.5
2.5.
in centimeters. So we need to check what is it in meters. So we're going to write 15.7 times 2.5 divided by 100. Can you please find this now?
0.39.
0.39 meters per second. Okay, very nice. All right. Anybody who would not understand this, Ahmed's and Juwaria and Gatika and Fahar, Arsalan,
No,
Mokshit.
sir, I understand completely.
Okay, very good. Now we want to find the acceleration and acceleration with respect to displacement. Anybody know the formula for that? A equals to minus omega squared x. Remember this? So if we want to find the maximum acceleration, we want to add maximum displacement. This was 15.7 whole square times displacement was 2.5 divided by 100. Okay, can you find the answer, please? All right, what you get?
So 6.16.
6.16. So
Negative 6.16.
Sir,
yeah,
is there a negative behind it?
come again, sorry.
Isn't there a negative behind it? Negative 6.16, right?
Okay, but because they say only write the magnitude, so we don't necessarily need to write sign. Okay,
Right. Okay, sir.
sign only gives you the direction. Okay, is that clear? Fahar, you understand? Nadia, everything is clear? Okay, very nice. Then it says the mass is now suspended from two springs. And you want to find okay, so it says suggest and explain the change, if any, in the period of oscillation of the mass. Numerical answer is not required. Okay. Anybody has an idea? So if it's so don't you think the force is going to be divided? Yes. Force, no? इसको देखो ये क्या कह रहा है बंदा अपने पास बिठा लो, मैं आ रहा हूँ, 5 मिनट रुकिए जरा. Okay, I'm really sorry about that. So, first of all, the thing is that obviously, whatever the weight is going to be, some of it is going to be, taken by this, and some of it is going to be taken by this. If they're both similar springs, then obviously, half of it, like W by 2, is going to be taken by this, W by 2 taken by this, right? Everybody agrees? Now, this question basically comes from the uh, the thing where you might have remembered that in AS we did that energy, elastic potential energy is half kx squared. You guys remember this? Right? So it says if it's suspended with two springs with the same, obviously, that the spring constant is going to be higher because now there are two springs holding it. Do you understand? So if the spring constant is higher, don't you think the energy is going to be higher then?
So why would the spring constant be higher?
Because Gatika, in
It'll be lower,
parallel,
right?
the total spring constants are added, right? So it is going to be 2 times the spring constant than before.
Sir, but the mass is distributed among them, so it will be less, right?
Yes, that's true. But force is equal to kx, right? You agree this?
Yes.
You agree? Now, for the
Yes, sir.
same extension, right? What you need to understand is the force here is the same. You agree?
The
Because
mass is same, yes.
yeah, the force is the same. The total spring constant is now 2k because in parallel k and k added. So it's much stiffer. You agree?
Sir, but I'm saying that the extension will be less, right? Because compared to, like, if you add the mass to one spring, the extension will be more. But if it's spread across both the springs, it will be less.
Yes, that's correct. Okay, sorry. My other internet, my phone got it. Anyway, so what I'm saying is, do you guys agree, at least to the fact that the spring constant is higher or not? What do you guys say? Right?
Yes, sir.
Okay. If the spring constant is higher, then definitely for the same amount of force, there will be less extension. That's what Mokshit is saying. You agree, Mokshit? Any disagreement on that?
No, sir. No.
Now, let me just explain this to you. So, since omega is basically acceleration is 2 pi by f, right? And x, right? So, imagine this. Acceleration is omega squared times x, right? Now, what is the relationship between omega and x? Is it inversely proportional or directly?
Inversely proportional.
Inversely proportional. If the
Yeah.
displacement is shorter, right? If the displacement now is shorter, right? So do you agree that omega will be smaller as well? Omega will be larger, right? You agree?
Sir.
If the omega, which is dependent on 2 pi by t, if omega is larger, what is happening to period? Will it be shorter or longer?
it will be
It's going to be longer because they're inversely proportional.
The period will be
It will be
shorter, right?
shorter because omega
No, wait.
shorter.
Oh my God, right. Never mind. Sorry.
Again,
It's the opposite.
again,
So
again,
you're
again.
confusing.
No,
I
sir,
said
I got
shorter.
it. Sorry, I got it. I just said it the opposite way. I got it.
Yeah, I just want to explain it to everybody again. Imagine. So we are saying that spring constant now is higher, right? Okay. Which leads to the conclusion that the displacement, which is the extension, is lower. You agree? Now,
Yes.
according to the equation, if the displacement is lower, then the omega is going to be higher. Force is the same, that causes the same acceleration. Do you understand? Omega itself is 2 pi by t. If the omega is higher, then the time period will be shorter. You agree?
Yes, sir.
So this is what we're going to write. That period, and the stiffness of the spring is now double. Is that is there anything that you guys did not understand? Please let me know.
So didn't we say displacement would be same?
No, I said for if the question was if they say we want to keep the displacement the same, right, Kartika? Then basically you would have to have more energy. You need to pull it harder then. But it says the mass is the same. That's fine. Okay.
Okay.
Force is the same. All right. Any questions, please? Munib, Nadia, Saman, Arslan, Pahar, Rafe. All right. All right. Great. Very nice. Now, the next thing we're going to do is this one. I just want to, complete this here so that we cover the maximum stuff. So as far as kinetic energy is required, right? Even if they ask you to derive this, which is rarely they're going to do. In fact, it has probably never happened. But you should, I'm just doing it so that you guys remember how to do it. Because when you hear kinetic energy, you always basically remember this equation. Am I wrong or right? You do remember this equation, right?
Always, yes.
Hello. Hello. Walaikum Assalam. आप बेल बजाए ना प्लीज. अच्छा 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 अहमद बेटा नीचे जाओ. एक बंदा आया होगा उसको ऊपर सर के कमरे में बिठा दो. सर अब वो कर लेते. ओके. और okay. Now kinetic energy equation is this now, and we know for the velocity equation in simple harmonic motion is plus minus x naught squared minus x squared. If I substitute this equation right here, what do I get? I get kinetic energy equals to half times m times plus minus omega x naught squared minus x squared whole square. Can I do that, please? Would you mind?
No, sir, you're
Sir,
correct.
could you repeat?
What I've done is, Munib, I have just put this equation right here in the kinetic energy
Okay,
that I.
sir.
Okay, do you understand? Okay.
Yes, sir.
So when you do that, you get this, and now you do half m. When you take square plus minus answer will be omega squared x naught squared. Just by remembering this,
Sir, you're lagging a little bit.
this equation already, so you can put it. You can get equation of m as Okay. All right. I don't know why this is that. Is it okay now?
Yes, sir.
Okay. So it will be half m omega square and x naught square minus x square. Can I write it like this? Will you remember this equation now? Now, I don't want to remember. I don't want you to remember this equation. What I want you to remember is kinetic energy equals to half m omega square. If I multiply this is going to be x naught squared minus half m omega square x square. Can I write it like this, please? Any issues? Okay, now think about it. The next thing I'm going to do is I'm going to write total energy. Now, conservation of energy says that whatever the total energy is, it has to be equal to potential energy plus kinetic energy. You guys agree?
Yes, sir.
Can I also say then kinetic energy will be equal to total energy minus potential energy?
Yeah, you can.
Now check something very, very interesting here. Take this equation, copy this, and write it right here. In this equation, you realize that this section of the equation tells you about kinetic energy. This section of the equation tells you about total energy, minus this section of the equation tells you about potential energy. Do you understand? So if you just remember this equation, you'll know that potential energy is half m omega squared x squared, and total energy is equal to half m omega squared x naught squared, and that's it. No need to remember three equations, just one, and remember that this is the relationship. You guys understand? All right, everyone.
Yes, sir. I'm just copying it down.
Yes, sir.
Yes, so this is as simple as this. Just remember this equation, and I also told you that even if you forget in the exam, you can always go through this path that I've shown you, and then you can find all the equations that you want. You don't have to, worry about it at all. So a lot of basically notes, books, and teachers would tell you to remember all three. I just say remember one, and that's it. Okay. All right. Any questions? Okay.
Yeah,
No,
for
sir.
today's.
All right. Now, the thing is that I would